In this lesson, we learn about the reflection section of the Coronamateria. So open up Node Material Editor and select this Coronamateria that has already been assigned to our shader ball to load its parameters. And run the interactive rendering. Let's enable reflection and go to the reflection tab. In the reflection portion of the Corona material, you can define how reflective you want your material to be. If we set the reflection level to 0%, we would obviously get no reflections. We only see the diffuse portion of our material because it's enabled. If we increase the reflection level from 0 to 100% gradually, we start making the surface more and more reflective, and at 100% it's fully reflective. Then we have this reflection color, which is white by default, but you can choose any other color. The reflection color should almost always be white for most surfaces, and the only time you need to actually change this color to anything other than white is when you're creating metal surfaces. For example, if you are making a gold material, this color should be changed to a yellowish color. We'll learn how to create metals in a moment. Also, the reflection level and reflection color multiply each other when determining the reflectivity of the surface. So if the reflection level is set to 100% and the reflection color is, let's say, set to this mid-gray, the reflection will be half as strong as when the reflection color and the reflection level were set to white and 100%. To see the reflections a bit better, let's use a very dark diffuse color or just disable it altogether. Usually reflections are much more visible on dark surfaces. Obviously, you can use a map to control the reflectivity of your material. Where the map is black, you see no reflections, and if it's white, you start to see reflections on your objects. But in Corona, you really, in most cases, you don't need a reflection map. You just need a glossiness map that we'll be talking about in a moment. But let's try adding a map to control our reflection. So in this case, let's right click and from the new shader menu, choose this load image option and load this BW3 map and connect it to the reflection texture input of the Corona material. Now the reflection amount is based on this map. When the map is white, we get a more reflective surface, and where the map is black, the reflections would be less. You can use this mix strength value to mix between the reflection color and the reflection map if you wanted to. For now, let's disconnect the reflection texture map and make sure reflection level and color are set to their defaults. We have reflection glossiness, which controls how sharp or blurry the reflections are. By default, it's set to 1, so the reflections are very, very sharp. And as you decrease this value, you see the reflections are becoming blurrier and more matte. Let's set it to probably something like 0.7 for now. As with other parameters, you can control reflection glossiness with a black and white map, where white pixel is going to cause sharp reflections and darker pixels are going to cause blurrier reflections. So let's connect the same BW3 map to the glossiness texture as well. So where the map is white, we see sharp reflections, and where it's darker, the reflections are blurrier. There is no mixed strength value for the reflection glossiness, but there is a very useful Corona node or map that makes it possible to do so. If you load the color mix node from the Corona nodes and connect it to the reflection glossiness input of the material, using this useful node, you can mix between a color and a texture. Right now, the color is set to white and we have no texture defined, so we get these very sharp reflections. If I start using darker colors, we would get blurrier reflections. So let's set the color to a 70% gray, which equals 0.7 value when using just the reflection glossiness value in the material. Now, if I connect the BW3 map to the texture or shader input of the color mix node, the texture takes over and controls the glossiness of the material. But in the color mix node, we can use this mixed strength value to mix between the color and the defined texture. So at 100%, we are using only the texture. And at 0%, the map is ignored and only the defined color, which is 70% gray, is used. And at 50%, we are using both the map and the value equally. Obviously, you can use any other value between 0 and 100%. For example, if I set it to, let's say, 10% of the map and 90% of the defined color will be used. For now, let's set it to 50%. So now the reflection glossiness is coming from both the color and the texture that we have defined. I'm going to select the main material again. In Coronamateria, reflection glossiness is the most important value in the reflection section. For most reflective materials, in most cases, especially when dealing with opaque materials like plastic, wood, ceramic, concrete, and so on, it becomes the only parameter to adjust. You just increase the reflection level to 1 and start adjusting reflection glossiness, and it will take care of the rest. We'll be back to this important topic in a moment. For now, let's continue on with the rest of these parameters. For now, let's disconnect this map and set the glossiness back to 1. The next important parameter is Fresnel IOR. So what is Fresnel? Fresnel states that the strength of a reflection on a surface is dependent on the viewing angle. If you look at a surface straight ahead in a parallel fashion, the reflections will appear a lot weaker. And as the surface becomes more perpendicular to your viewing direction, the reflections are going to become much stronger. Think about a swimming pool. If you look at it at an angle, you can see the water is very, very reflective, and it's hard to see the bottom of the pool. But if you look at it straight from above, the water is becoming less reflective and you can simply see the bottom of the pool. And that is Fresnel. It's everywhere. It's such a universal phenomenon. So this is what Fresnel reflection is doing, and Fresnel IOR value here is what controls how strong the Fresnel effect is. Let's set the IR value to 1.1. As you increase the IR value, you're actually making the Fresnel effect less noticeable. So low values like 1.1, 1.2 are going to show a very, very strong Fresnel effect. As you can see, the frontal or parallel angles are less reflective compared to the edges or more perpendicular angles. You can clearly notice how more reflective the edges are, and as we increase the IR value, we are basically making the reflections to be more even from different viewing angles. So let's go from 1.1 to 1.6. Now, as you can see, the Fresnel effect is less visible and the reflections are more even on the surface. Let's go to something like 3. And now the Fresnel effect is even weaker and the overall reflection seems stronger. And if you keep increasing this number, you will notice that at something like 50, we have almost a chrome-like material. And now the Fresnel effect is so weak that it's almost invisible. One interesting thing is in almost all the materials in real world, the reflections at the very edges of the surface to the viewing direction are almost mirror-like, even though it's very hard to notice those very reflective edges. So as we increase the Fresnel IOR value, we are making the reflections at frontal or parallel angles more even to the reflections at the edges or perpendicular angles to the viewing direction. That is why at a high value like 50, we can see this mirror or chrome-like surface. Basically, the frontal reflections now are almost as strong as the reflections at the perpendicular angles. The IR value is normally from 1 and then it goes up. For most cases, you can leave this value at around 1.5 for plastic, wood, concrete, and stuff like that. But for transmissive objects like water or glass or diamond, you need to find that specific IOR value and enter it here. And for metals, if it's clean, polished metal, the Fresnel value should be disabled, which you do that by setting the Fresnel value to 999. But if it's a dirty, less polished metal, it can be set to lower values like 3, 6, 10, 20, and so on. We will be talking about this concept and how it relates to reflection, glossiness, and PBR mode later on. For now, let's set the Fresnel IOR to 999. Now we get a chrome-like material, and let's set the glossiness to about 0.8. When creating metal materials, the diffuse level should be 0 or very, very dark. Next, we have anisotropy amount and rotation. By default, at 0.5, your reflections are isotropic. You can use the anisotropy value to introduce some anisotropy or stretched highlights to your reflections. Let's increase anisotropy value to something like 0.7. And as you can see now, we get some stretched reflections in a certain direction. Now let's use a value like 0.3. And now the reflections are stretched in another direction. I'm going to set the value to about 0.8. Next, we have rotation, which controls the orientation of the anisotropy effect. So if I set it to something like 90, you can see we have rotated our highlights by 90 degrees. I'm going to try 130 degrees. And set the rotation back to 0. We can produce some amazing effects by mapping anisotropy amount and rotation. Let's load this map called anisradius.png and connect it to the anisotropy amount and rotation. I'm going to set the overall tiling for this material to 3 and 3 and wait a bit to see what we get. And look how nice it is. Let me disconnect this map for now and set the anisotropy amount and rotation back to their default values. Also set the reflection level, glossiness, IOR, and diffuse values back to the default amounts by right-clicking on their spinners. Now I want to discuss how to use reflection level, glossiness, and Fresnel IOR values to create different materials. If you are coming from other render engines, you probably tend to adjust and alter all of these 3 parameters to get the shader that you're looking for. For example, if you wanted to create a yellow plastic, you would set the diffuse color to yellow. reflection level to something like 40-50%. Glossy